I feel if you don't have a passion for learning new things, then you cannot get anywhere in this present era.
Hi everybody, my name is Samir and we are at the Digital Engineering Club Offstage with Beena Anand. The Digital Engineering Club is a community where the best of the world come and share the best practices, the triumphs, the tribulations, the success and the failure, but most importantly, learning in the era of engineering intelligence. Beena Anand has been recognized as the Digital Engineering Award of the year 2026. Please tell us something about your journey so far and what has been your inspiration.
Thank you, Samir. Thanks for the recognition and this opportunity. So it has been a 25 plus years professional journey. Early on, I started as an embedded programmer working on low-level firmware development, software driver development, platforms and system bring up. I joined Intel about 10.5 years back, and at Intel I'm part of the data center group, the Xeon validation team. So it started off as silicon validation, but very soon branched into systems and rack scale validation. And I work extensively with customers. So that has been the area that I focus on currently at Intel. So on the personal front, I think I lost my husband pretty early and raised two boys as a single parent. I think that has played a significant role in shaping my resilience and sense of responsibility. I think the experience has taught me to be grounded and to stay focused through challenges. I believe I've taken that mindset into my professional journey as well. So the rapid pace at which the technology is evolving these days, incredibly inspiring. Like working with customers, understanding what their pain points are and solving their problems at scale, incredibly exciting. I work with a very passionate team at Intel, and when something new emerges, everybody rallies together, tries to solve all these complex problems, and I think that is cool and keeps me going. And all along the way we try to grow others, and that is a natural part of how we succeed.
AI is pushing engineering teams to move faster than ever before while still delivering reliability at hyperscale. From your perspective, what really separates high-impact engineering teams today from the teams that simply just keeping up?
Samir, I would say here mindset is the key. We need to be proactive these days rather than reactive. You cannot wait for something to happen and then react to it. We need to shift left, start early, collaborate early, and have the mindset of continuous learning and adapting. You cannot rely on rigid processes. So the key differentiator is optimization. I feel teams that are continuously keeping up look at a component level. They are optimizing each metrics at a component level. It is very difficult because if you're a high impact engineering team, you think of system level throughout the life cycle. You optimize everything at a system level. For instance, if you take CPU, if you're going to optimize the CPU for power or performance without thinking, how the thermal profile in a rack is going to be, it's not going to fly. If you think of a networking problem, you optimize your network for bandwidth, but you're not thinking about the memory footprint. It will not work when you put everything together. Again, if you're validating for using synthetic tests, but don't think of what a real world workload would look like, it doesn't work. So, end-to-end validation, but optimizing for scale, performance, reliability, that is what I think is the hallmark of a high-impact engineering team.
What matters more today? The deep technical expertise or the ability to think across systems, customers, and business impact?
Deep technical expertise is no doubt foundational, but it is not sufficient these days. You need to think system, you need to think customers and business impact.
So, Beena, you have led rack scale validation for AI and distribution workload at times where traditional testing models are being stretched by speed and scale of AI infrastructure growth. Was there any moment where you realized engineering team had to completely rethink how the validation approach especially in the AI era?
Yes, definitely. So, traditionally we've been doing single node validation, and it is, benchtop validation. You have just standard domain level test cases. You have a IO subsystem, PCI or memory subsystem, and you're doing your traditional validation. We began to see that customers are seeing an issue, or there are issues when you put together, when they put the systems together in the fleet, but we are not able to reproduce in the lab. And then we realized, okay, our SoC or our silicon is subjected to a different traffic pattern in real life because the power profile is different, the thermal profile is different when multiple nodes come together. Now there is a fabric at play, there is a network at play when the issues don't crop up within the SoC, within a node, but when two nodes talk to each other across the fabric, issues were cropping up because concurrency, like different interfaces or subsystems are stressed differently within the silicon. Then we realized, okay, we cannot stop with the way that our traditional validation. We need to go beyond our traditional validation. We need to think like systems. We need to think like customers, both in the hardware wise, the workload wise, move from synthetic validation to real workloads and real use cases.
One of the biggest challenges in engineering today is the innovation cycles are accelerating, but the customer tolerance of failure is shrinking, How do you balance speed, scale, and reliability when teams are building for hyperscale environment where even small issue can create massive downstream impact?
Scale, reliability, all are not competing priorities anymore. Like they all need to be engineered together. So it is a proactive approach. Early alignment, super important here. Alignment across all the teams, design, architecture, validation, customers, so that, we are solving the right problems even before they scale. End-to-end validation, Samir, I would say is the key here because you need to validate across compute, across memory, across IO, power, and using real workloads and not just synthetic tests. And nowadays, telemetry, monitoring and learning continuously from the telemetry data, from the deployment signals is very important. So validation doesn't stop at pre-release, but evolves with real usage. So speed without system awareness is pretty prone to risks. So when you start early, partner early, look at problems, solve them early before they scale, then I think you can build systems at scale and reliability.
The industry is moving towards more ecosystem-led engineering where silicon, software, product providers, OEM and customer all influence the final outcome. From your experience, what makes collaboration actually work in these high-stake engineering environments?
See, now the ecosystem has changed, right? It is no longer a silicon vendor, like Intel being a silicon vendor. We need to work with our OEMs, our customers. Here, I would say co-engineering. I use that word so many times in a day. That is the key. We work very early with our customers. Earlier on, it would be after silicon arrives. Now it is way before silicon arrives. Come up with cool ways on, validating this interface or this software or this flow much before the silicon arrives. So when we validate alongside our customers and partners, we need to have a common goal. See, the data is shared. There is clear visibility. There is a sense of ownership, shared ownership, and a common definition for success.
As someone who has been driving transformation firsthand, what do you think the role of digital engineering will look in 3 years from now?
AI is transforming everything, right? From architecture, validation, deployment, optimization. We see AI everywhere. AI can significantly accelerate our execution, but the real value is somebody needs to define the right problem, set the right constraint, and interpret outcomes in a full system context. That is what the role of a digital engineer will change, I think, going ahead. Engineers need to think end-to-end across silicon, systems, workloads. They cannot be operating in isolated domains, and they'll need to optimize continuously. It is actually a continuous learning, and I think the role will also move closer to customer and business impact because whatever decisions they make with all this AI help, etc., it needs to be translated into a good customer experience and something that is relevant and important to the customers.
What human capabilities will become more important for the future engineering leaders?
First is define the right problems and make sure that the alignments, the outcomes are relevant to what the customer needs. Define the right problems, frame the right problems, ensure the result is what the customers need. And now we don't work in silo. So many people are involved, internal and external. Within the organization, you need to work across different teams, software, hardware, design, architecture, validation. An engineering leader needs to bring everybody together. And outside, like you mentioned, your vendors, your partners, your ODMs, your customers. So I think it is super critical that in this changing technology world, the leader brings everyone together. Alignment is so important. I think empathy also. Is nowadays understanding customer needs, team dynamic, real world impact on technology. I think a leader should have that empathy.
We'll move to the interesting part, which is a quick rapid fire kind of thing, which we call as the DA Offstage quick fire. So a tougher challenge today, building faster or validating smarter?
Validating smarter.
One thing AI will dramatically improve in engineering workflows.
Quicker decision velocity, taking quicker decisions.
The future belongs to specialists or system thinkers?
My answer, system thinkers all the way.
Not surprised at all. If you could redesign one engineering process from scratch today, what would it be?
Validation. It used to be discrete. Now I think it should be continuous and learning. I feel if it had been that way, it would have been awesome.
One underrated habit of a great engineering leader?
Listening early, especially to signals from teams, customers, even before issues arise. That is totally underrated these days.
One word that defines the future of digital engineering?
Orchestration. Everything together.
Awesome. Beena, that was awesome. At LTTs, we often talk about engineering intelligence and the convergence of engineering and digital technology and AI. From your perspective, how is this convergence changing the way organizations innovate, building products and create competitive advantage? What's the key takeaway?
There is a fundamental shift now. So innovation is no longer design-led. I always say it is insight-led. Earlier, we would say, hey, draw the specification. Somebody draws the design specs. Then there is somebody to validate it. And then you wait very late in the cycle to get real-world feedback. But nowadays, that is not the case. It is all insight-driven. You have data very early on. Like I always say, continuously learning. You build models. You get real-world feedback very early. So innovation has totally shifted. And we don't just build products now. We are building intelligent adaptive systems that almost like adapting very smartly to real world data. So this is enabling faster innovation throughout. I think throughout the industry, I think that the pace and rate and scale of innovation has changed dramatically. And it also brings a stronger alignment to customer outcomes, because now how we translate all this to competitive advantage. You have so much of data. Now you need to take the data and see what is meaningful and translate these into decisions that will give you the right product at scale, reliable, and so that you get a good customer experience.
And one lesson from your journey that every engineering leader should carry forward into the AI era?
The biggest lesson is we need to change or evolve from managing executions to guiding outcomes. See, in an AI era, the speed will come from tools. You will get the speed. But ask the right questions, I think. Again, focus on system level thinking and align teams for real world impact, not just technical milestones.
Beena, you have an illustrious career. Being a single mom who has raised two budding youngsters, you single-handedly manage work-life balance. What's the secret sauce?
Personally, I'm a strong proponent of meditation. Generally, most of the times I start my weekday with meditation. I think I've been practicing something called passage meditation from 2010 or 9. Okay, my day is not made if I don't meditate. Because when you're juggling so many things, you tend to get overwhelmed, and I feel if I don't meditate, by the end of the day, I lose my cool and I start yelling. So I think meditation has played a key role. It brings focus, and from my experience, I can truly say that I've seen the benefit. I always used to tell my sons, happiness is a choice. I think I kept repeating it in the early stages. They were 3 and 6 when my husband passed away. And maybe I was trying to believe that myself by repeatedly telling them happiness is a choice. On the work front, I've seen many youngsters overthinking when they take up a project, or even especially women. Like, to give an example, my son is in high school. I don't want to take a tough project work. See, opportunities don't come every time. See, family is important. We need to balance our family and work. But somehow I feel that if you sign up for it, we'll make things work. It's not like every day is going to be super busy with work. You can juggle both family and work and somehow make things work. And I feel if you don't have a passion for learning new things, then you cannot get anywhere in this present era. So that is what keeps me going.
Beena, I hope my daughters can be half as good as what you are. Thanks, Beena. Goodbye.
Thank you so much, Samir.